This is an AS FP2 question on first order recurrence relations. A tree at the bottom of a garden needs to be reduced in height. The tree is known to increase in height by 15 centimeters each year. On the first day of every year, the height is measured and the tree is immediately trimmed by 3% of this height. When the tree is measured before trimming on the first day of year 1, the height is 6 meters. Let Hn be the height of the tree immediately before trimming on the first day of year n. Part A, explain in the context of the question or the problem why the height of the tree may be modelled by the recurrence relation Hn plus 1 is equal to 0.97 Hn plus 0.15, where H1 is 6 and n is in the set of positive integers. So let's start by explaining what H1 equals 6 means. So this represents the height of the tree at the start of year 1 before trimming. Next, Hn, and this represents the height of the tree at the start of year n. Then 0.97 Hn, so that's this bit here. And this represents the height of the tree decreasing by 3%. And that's because a decrease of 3%, the multiplier of that would be a multiplier of 0.97. Then next, the 0.15, which is here. Now I've underlined each one of them just to make it easier to see. And this represents the height in meters that the tree grows each year. Now remember, we're told that it increases in height by 15 centimeters, but the initial height is given in meters. So that's why we need to change that 15 centimeters into meters, and that's why we've got 0.15. So putting this all together, what we've got is to calculate the height of the tree in the next year. It's going to be the height of the tree in the previous year, 97% of the height in the previous year, because 3% of the tree is trimmed off, plus this 15 centimeters of growth, or 0.15 centimeters of growth, with the initial height of the tree being 6 meters. Part B, prove by induction that Hn is equal to 0.97 to the power n minus 1 plus 5, where n is greater than or equal to 1. Okay, first step in any proof by induction is proving that this statement is true for n equals 1, the smallest value of n in this case. So that should give us that H1 is equal to 0.97 to the power n minus 1. Okay, and n is going to be 1, so the power 1 minus 1, which is the power 0, plus 5. So that gives us H1 is equal to, when anything to the power 0 is 1, 1 plus 5, which gives us H1 is equal to 6. So what we have, so statement is true for n equals 1. So our next step is the assumption step, where we make an assumption. So we'll start with n is equal to k, and we substitute that into what we have here. So we'll have hk is equal to 0.97 k minus 1 plus 5. And then what we're going to do is we're going to take this and we substitute it into the recurrence relation to come up with an equation for hk plus 1. So that's going to be 0.97 times the previous term, and our previous term we've written in terms of k, so that'd be 0.97 to the power k minus 1 plus 5. Okay, so basically that just gets substituted here, where I've got hn plus 0.15. So what we're going to do now is expand the brackets to see what that gives us. So if I multiply these terms together, this power will go up by 1, so that'll be 0.97 to the power k. and then we're going to do 0.97 times by 5, so 0.97 times 5, so that gives me 4.85, so plus 4.85 plus the 0.15, which I believe is 5, so we've got hk plus 1 is equal to 0.97k plus 5. So that completes our proof by induction, apart from the conclusion at the end. So you can see here, actually let me just highlight it, where I've assumed it's true when I've got k, okay, and I've got k minus 1 here. Then if it's going to be true for k plus 1, then this power here needs to be k minus 1 plus 1, which it is. Okay, so I guess you could write that as k minus 1, which was the previous power, plus 1. So now we'll write out our conclusion. So if the statement is true for n equals k, that was our assumption, and true for n equals k plus 1, and it's also true for n equals 1, therefore the statement is true for all of these positive integers, Zahlen plus. Part C, explain what will happen to the height of the tree immediately before trimming in the long term. Now in the long term, n is going to get bigger and bigger and bigger. So I guess we want to find a limit as n approaches infinity, or just a large number rather than infinity. Whenever you do a decimal, a number between 0 and 1 to a large power, it just gets smaller and smaller and smaller as you increase the power. So after a long period of time, we can sort of ignore this bit. It's going to be tending towards 0. So I can write down here the limit as n tends to infinity of 0.97 to the power n minus 1. Well, this is tending towards 0. All that's left is the 5. So we could say that after a long period of time, the height of the tree will tend towards or approach 5, and that's 5 meters. I want to make sure it's in context. Part D. By what fixed percentage should the tree be trimmed each year if the height of the tree immediately before trimming is to be 4 meters in the long term? Now for this we need to go back to our recurrence relation here that we had in part A, and if we want the height of the tree to be 4 meters in the long term, what we want is sort of hn to be 4 and hn1 or hn plus 1 also to be 4. So the height sort of just going to this 4 and not changing. Now the height that the tree grows each year, that doesn't change. We can't do anything with that. But this is the percentage, or this represents the percentage of the trimming each year. So we want to do something with that. We basically want to work out what percentage it should be. So if I put those numbers into that recurrence relation, so I want the next height to be 4, I want the previous height to be something times by 4, let's call that x, so 4x, so x is going to be this multiplier that I can use to work out what the percentage that should be trimmed each year, plus 0.15. So I want to solve this, so we'll take away 0.15 from both sides, and that will leave us with 4x is equal to 3.85, dividing both sides by 4 to get the multiplier. So let's have a look. 3.85, let's divide that by 4, get 77 over 80. So that gives me x as 0.9625. Now remember, that's the multiplier, so I'm going to do 1 minus that, which is 3 over 80. That will give me the percentage decrease, which is 0.375. So I'll just write down I just did 1 minus x to get 0.375. Sorry, 0.0375. So this tells me that the tree needs to be trimmed by 3.75%. Okay, so so the tree should be trimmed by 3.75% each year if I want the height of the tree to be 4 meters. Now this makes sense because previously it was 3% that was trimmed, and it's going to become 5 meters in the long term. And if I want it to be shorter, I'd expect to decrease or trim by a slightly larger amount than the 3%. So that sort of fits with what I would expect.